base 10 should be converted to the base 10 should be converted to base 2 system. That is base 10 should be converted to base 2 system. For example, if I am having a number called 17 of base 10, which should be converted to base 2. So the required base is 2. So I am going to divide the given number with 2 number. So the number is 17 should be divided with 2. So 2 how many times does it go? 8 times. 2 8 is 16. Remainder is 1. So again I am dividing 8 with 2. That is 2 4s are 8. Remainder is 0. Next I am taking the other number. 2 2s are 4. The remainder is 0. Next 2 1s are 2. Remainder is 0. So my number is in binary 1 double 0 triple 0 1. Means I need to collect all the reminders in the reverse order. So this is the binary conversion. Now there will be normal numbers which are also provided. Like this is a normal 17 number. If a fractional number is provided, for example, if I am having a number called 12.125, 12.125 to the base 10 he has given. Now I want to convert it to binary. So what can be done? I will separate 12 and 0.125 separate. Now you know the procedure how to calculate the normal number binary. That is 12 should be divided with 2. That is 2 6 are 12. Remainder is 0. 2 3s are remainder is 0. Next 2 1s are remainder is 1. So my normal number for 12 is 1100. Now 0.125 is left. So what can be done? So I will take this 0.125 should be multiplied with required base, that is 2. So what I am going to get when I multiplied? I am going to get 0.250. Now in this I am going to separate two things. One is decimal and the other one is fractional. Now here decimal is 0, fractional is 0.25. Now again multiply 0.25 with 2. So what I am going to get? I am going to get it as 0.5. So decimal value is 0, fractional value is 0.5. Again multiply 0.5 with 2. You are going to get 1. So decimal value is 1, fractional value is 0. So my binary converted value I need to consider from top to bottom approach. So this is fractional value. So I am considering 0.001 as binary equivalent for my 0.125. So when I combine these two values, I am going to get it as 1100.001 to the base 2 as my required value. So this is how we are going to do the conversion from decimal to binary. Next slide, we'll get on to the next thing. Now the thing is we are going to consider the binary to decimal conversion now. Let us see binary to decimal conversion. Now for example, I got a number uh, 0 1 0 1 0 1 to the base 2. It should be converted to base 10. So binary number is a positional value system. So I need to multiply the given number with its positional values. So let us consider each position. Let us consider the first position, that is MSB bit 1 into 2 power 0 plus next bit. I am considering next bit 0 into 2 power 1 plus 1 into 2 power 2 plus 0 into 2 power 3 plus 1 into 2 power 4 plus 0 into 2 power 5. 2 power 4 is 16 plus 0 plus 4 plus 0 plus 1. So that is 16 plus 4 is 20. 20 plus 1 is 21 to the base 10 is the required answer. Now similarly, there might be a chance of having a fractional values here also. For example, if I am having value 101.10 to the base 2, which is asking to convert to decimal. So what can be done? So before point I need to multiply with positive powers of 2. After point I need to multiply with the negative powers of 2. So now it is 1 into 2 power 0 for this bit. Next 0 into 2 power 1 plus 1 into 2 power 2. Less after point 1 into 2 power minus 1 plus 0 into 2 power minus 2. So this value is going to be 4 plus 0 plus 1 plus 1 by 2 is 0.5. So my value is going to be 4 plus 1 5, 5 plus 0.5 is 5.5 is my decimal equal. Next thing, we'll get on to the next topic, that is decimal to octal conversion. Decimal to octal means I need to perform the operation of base 10 should be converted to base 8 system. For example, if I am having number called 658.825 to the base 10 to be converted to octal. So I will divide the given number 658 plus 0.825 as two separate numbers. So 658 should be divided with 8. So when I am dividing with 8, it comes to 82 times. 882 times will give me 656. Next again 8 10 times gives me 2 as remainder. Next 8 ones are 8, 2 is the remainder. So my answer for my 658 is 1222 to the base 8. Now I am left out with 0.825, which can be converted to octal by just simply multiplying with the required base, that is with 8. So when I am multiplying with 8, I am going to get it as 6.6. So again divide the resultant number into decimal part and fractional part. Now decimal part is 6, fractional part is 0.6. Again multiply 0.6 with 8, which you are going to get it as 4.8, where 4 is decimal, 0.8 is fractional. Next multiply 0.8 with 8, which is you are going to get it as 6.4. So 6 is decimal, fractional is 0.4. So collect all these things in the top down approach, that is 0.646 to the base 8. Now combine these two numbers, you are going to get 1,222.646 to the base 8. So this is how the conversion goes from decimal to octal conversion. Let's get on to the next thing, that is octal to decimal conversion. Octal to decimal conversion. Let us see. That is base 8 should be converted to base 10. For example, if I am having 372 to the base 8, I want it in decimal. So what can be done here? Just multiply with its positional weights, that is 2 into 8 power 0 plus 7 into 8 power 1 plus 3 into 8 power 2. 8 8 is 64. 64 into 3. 3 4 the 12. 3 6 the 18. 19. 192. Next 7 8 ja 56. 2 1s are 2. So what is the value? 192 plus 58. So the total value coming it as 192, 58, 10, 15 to 50. So my value is 250 to the base 8. Similarly, if I am having a fractional value, for example, if I am having 12.34 to the base 8, I want it to be converted to decimal. So what I can do, 2 is multiplied with 8 power 0 plus 1 is multiplied with 8 power 1 plus 3 into 8 power minus 1 plus 4 into 8 power minus 2. Calculate the value, you are going to get the value in decimal. This is how the conversion goes for octal to binary conversion. Sorry, decimal conversion. Next is decimal to hexadecimal conversion. Means I am going to convert the given decimal number from base 10 to base 16. Means if I am having a value called 5386 dot 345 to the base 10, I want it to be converted to base 16. So we'll do one thing, we'll separate two things, 5386 plus 0.345. So 5386, let's divide it with 16. So how many times does it go? It goes 336 times of base of remainder 10, that is A. Next again 16 is divided with 21 times, which gives remainder as 0. Next 16 is divided one time, remainder is 5. So my answer for 5386 is 150A to the base 16. I am left out with 0.345, which is multiplied with the required base 16. So I am going to get it as 5.52. Now divide differential part and fractional part, that is 5 and 0.52. Now again multiply 0.52 into 16, that is you are going to get it as 8.32, that is 8 and 0.32. Now again multiply 0.32 into 16, that is you are going to get it as 5.12. 5 as differential part and 0.12 as now correct top down approach, that is 0.585 to the base 16. So combine these two values, 150A dot 585 to the base 16. So this is how the conversion goes like this. Now let us see, let's get on to the next thing, hexadecimal to decimal conversion. Hexadecimal to decimal conversion, where the base 16 to be converted to decimal. Means if I am having a number called A3 B4 to the base 16, I want it in base 10. Just multiply with its positional values. If I'm taking one more simple number, 3 4 to the base 16 to be converted to 16. So 4 into 16 power 0 plus 3 into 16 power 1. So what I am going to get, 3 16s are 48 plus 4. So I am going to get it as 52 to the base 10. So this is how the simply you can get your value